Hi everyone, welcome to my YouTube channel Maths Academy by Sudhir, and I am Sudhir Desai. So in this video lecture we are going to study inverse of matrix A using adjoint method. So let us see what is the definition of inverse of matrix. If A is any square matrix, then inverse of A is denoted by A to the power -1, and it is read as A inverse and is given by the following formula. A inverse is equals to 1 upon determinant of A into adjoint of A. Here note that determinant of A should not be equals to 0. I will repeat the formula again. A inverse is equals to 1 upon determinant of A into adjoint of A. So let's see what are the steps to calculate inverse of any given matrix A. So step 1, calculate determinant of matrix A. Step 2, find cofactor matrix of A. Step 3, find adjoint of matrix A. And step 4, find A inverse using the formula. What is the formula? 1 upon determinant of A into adjoint of A. So let's use these 4 steps to find the inverse of the following matrix. So find the inverse of matrix by adjoint method, and this matrix is given to us. So first consider this given matrix as A. Now what is the step 1 to find the inverse of any matrix A? Is to calculate determinant of that matrix. And in previous video lectures we have seen how to find the determinant of given matrix. So determinant of A is calculated by replacing square bracket with 2 vertical lines. So replace the square bracket with 2 vertical lines and elements will be as it is. Now you can see that this is a determinant of order 3 by 3, and we know that how to expand a determinant of order 3 by 3. So let's expand it. So determinant of A is equals to plus first element 1, then this one is in first row first column, so delete it, and then write down these 4 elements in a determinant of order 2 by 2 and take its cross multiplication. So -1 into -1 is +1, middle sign minus, 1 into 1 is 1. Now sign for the second one is minus and second element is 1. Now this is in first row second column, delete it. Whatever the elements are remaining, write it down in the 2 by 2 order determinant and expand them by taking cross multiplication with middle sign minus. So 2 into -1, -2, middle sign minus, 1 into 3, 3. Now sign for the last determinant is plus and third element is -2. Now this -2 is in first row third column, delete it, and whatever the remaining elements, take its cross multiplication with middle sign minus. So 2 into 1, 2, middle sign minus, -1 into 3, -3. Okay, now let's simplify this. So determinant of A is equals to, here you can observe that 1 minus 1 will become 0 and 0 into 1 is 0. Next, -2 minus 3 is -5. When it is multiplied to -1, so minus minus will become plus, and 5 into 1, 5. And lastly 2 minus minus will become plus 3, so 2 plus 3 is 5, and when I multiply it to -2, so 5 into -2 is -10. So therefore determinant of A is equals to 0 plus 5, 5, 5 minus 10 is -5. So this is the first step to calculate determinant of given matrix A. So what is the value of determinant of A? -5, and it is a non-zero number. So inverse of this given matrix exists. Now what is the step number 2? is to find cofactor matrix of A. So therefore cofactor matrix of A is equals to, now cofactor matrix is divided into two parts. So first we have to give a signs. Now as there are 9 elements in this matrix A, so there will be 9 cofactors. So first we will write the signs column wise. So sign for the first element is plus, then next minus, you just have to alternate the signs. Next plus, now next sign will be what? Minus, plus, minus, just alternate the signs, plus, minus, plus. And as there are 9 elements, so we will get 9 minus in the form of 2 by 2 order determinant. So now how to find minor of each element of matrix A? How to find? We have seen this in previous video lecture by deleting row and column in which that element presents. So let's find minor of the first element 1. How it is obtained? By deleting first row, first column in which that element is present. So minor of this one is minus 1 1 1 minus 1. This is the minor. Now next, minor of the second element 1 is obtained by deleting first row, second column. So the remaining elements are 2 1 3 minus 1. Write them inside the 2 by 2 order determinant. Now minor of minus 2 is obtained by deleting first row, third column, which is 2 minus 1 3 1. Now next, minor of 2 is obtained by deleting second row, first column, which is 1 minus 2 1 minus 1. Okay, minor of minus 1 is obtained by deleting second row, second column, which is 1 minus 2 3 minus 1. And minor of 1 is obtained by deleting second row, third column, which is 1 1 3 1. Now let's find the minor for the last row. So minor of 3 is obtained by deleting third row, first column, which is 1 minus 2 minus 1 1. Minor of 1 is obtained by deleting third row, second column, which is 1 minus 2 2 1. And finally minor of minus 1 is obtained by deleting third row, third column, which is 1 1 2 minus 1. I hope students you are liking this video, so please do not forget to subscribe to my channel Maths Academy by Sudhir for more videos. Let's see. Now cofactor matrix of A is equals to, we just have to simplify these 2 by 2 order determinants by taking cross multiplication with middle sign minus. So plus, let's expand this determinant first. So minus 1 into minus 1 will plus 1. Middle sign minus, 1 into 1 is 1. Next, minus expansion, 2 into minus 1 minus 2, middle sign minus, 1 into 3 3, plus 2 into 1 2, middle sign minus, minus 1 into 3 minus 3. Now come to the second row, sign again minus, expansion 1 into minus 1 minus 1, middle sign minus, minus 2 into 1 minus 2. Next plus 1 into minus 1 minus 1, middle sign minus, minus into 3 minus 6, minus 1 into 1 1, middle sign minus, 1 into 3 3. Last row plus 1 into 1 1, middle sign minus, minus 2 into minus 1, minus minus will become plus, and 2 into 1 2. Next minus 1 into 1 1, middle sign minus, minus 2 into 2 minus 4. And finally plus 1 into minus 1 minus 1, middle sign minus, 1 into 2 2. Now in the next step we are going to simplify these brackets. Okay, so let's calculate these brackets. So cofactor matrix of A is equals to, 1 minus 1. What is the value 1 minus 1? 0. Now for the second element, minus 2 minus 3 is minus 5, and because of this outside minus it will become plus 5. So do this calculation carefully. Next, 2 minus minus will become plus, so 2 plus 3 is 5. You just have to change the sign if minus sign is outside the bracket. First solve the bracket and then give that minus sign. So minus 1 minus minus will become plus 2. So minus 1 plus 2 is 1, and because of this minus it becomes minus 1. Now minus 1 minus minus is again plus, so minus 1 plus 6 is 5. Next, 1 minus 3 minus 2, and because of this minus sign it will become plus 2. 1 minus 2 is minus 1. 1 minus minus plus 1 plus 4 is 5, and with this minus it becomes minus 5. And finally minus 1 minus 2 is minus 3. So friends, this is the cofactor matrix of A. This is the step number 2. Now what is the step number 3 for finding the inverse of the matrix? Is to find adjoint of that matrix A. So memorize what is the formula for finding adjoint of any matrix A. It is cofactor matrix of A, its transpose. So let's take the transpose of this cofactor matrix of A to find adjoint of A. So adjoint of A is equals to cofactor matrix of A. This is the cofactor matrix of A. So we have to take its transpose. And how to obtain transpose? By interchanging rows into columns. So we have to change rows of cofactor matrix into columns. So let's change row 1 as a column 1. So elements will be 0, 5, 5 in C1, column 1. Row 2 will change to column 2, minus 1, 5, 2. Row 3 will change to column 3, minus 1, minus 5, minus 3. So after interchanging rows into columns of cofactor matrix, the matrix obtained is adjoint of that matrix. Okay, so now next final step is to find A inverse, but using the formula. What is the formula for A inverse? 1 upon determinant of A into adjoint of A. So let's use this formula. Previously we have calculated the values of determinant of A and adjoint of A. Just we have to substitute these values in this formula. So therefore A inverse is equals to 1 upon, what is the value of determinant of A? Minus 5 into value of adjoint of A. Here it is. So it is this matrix. So this is the only step for finding the inverse of matrix. So we are not going to simplify further. It is sufficient answer. So inverse of the given matrix is 1 upon minus 5 into the matrix 0 minus 1 minus 1, 5 5 minus 5, 5 2 minus 3. So students, I hope you understood this method of A inverse using adjoint method. Thank you for watching this video. Please subscribe to my channel Maths Academy by Sudhir. Thank you.